We are continuing with simultaneous equations today. We're finished with the elimination method, so now we have to learn the substitution method. Before we do the substitution method, I want to just review removing brackets. Right? So this is something that you would have done in Form 2, moving brackets. It's important for you to understand how to remove brackets because in the substitution method, you're going to have to do that, right? So to remove brackets, we use the distributive law. So for example, let's say I have um, 5 times x plus 2. Well, this would simply be the distributive law means that you multiply the term on the outside of the bracket by each term on the inside. So this will be 5 times x, which will give me 5x, and then 5 times positive 2, which will give me plus 10, right? So that's the distributive law, removing brackets. The reason I said positive 2 just now is because if I had 5 by x minus 2, then this would be 5 times x, which is 5x, and then 5 times negative 2, which will be negative 10, right? So the sign changes the, the answer because, just to refresh, when you're multiplying or dividing by numbers, directed numbers, two positives or two negatives give you a positive. So same signs when multiplied or divided by each other give you a positive. And different signs when multiplied or divided by each other give you a negative, right? So when you're removing brackets, you have to be sure to pay attention to your signs. So again, like if I had negative 5 instead on the outside by x plus 2, well, that would give me negative 5 times x, which is negative 5x, and then negative 5 times positive 2, which is negative 10, right? And let's say I had negative 5 by x minus 2. Well, this would be negative 5 times x, which is negative 5x, and then negative 5 times negative 2. A negative by a negative is a positive. So this would be plus 10. So that's important for you to get your mind, just refresh your memory with removing brackets because it's important in the substitution method. Also, if you just see, like for example, let's say I had 10 plus 3 times 2x plus 1, right? Now, a common mistake that students make is that they add this 10 and this 3 and then they multiply it by the brackets inside. That is not correct, okay? You have to actually work out your brackets first and then add 10 on the outside because this problem here, 10 plus 3 brackets 2x plus 1, literally means 10 plus the product of 3 and 2x plus 1. So 10 plus 3 times 2x plus 3 times 1. That's what it is. So whenever you see a problem like this, you do not add this 10 to the 3 on the outside because that 3 is part of this part of the problem here, right? And if you recall your order of operations, when you have multiple operations, you recall BODMAS, brackets of division, multiplication, addition, subtraction, right? So you have to work out your brackets first. And even self, you have to do multiplication or division before you add. So you would have to work out 3 by 2x plus 1 and then simplify by adding your like terms, right? So to expand this, I would first remove the brackets. I'll keep 10 by itself because I'm not going to do anything to 10 as yet. And this will be 10 plus, well, 3 times 2x, which is 6x, and 3 times 1, which is 3. And now I have the like terms 10 and 3. So I write that next to each other. So that's 10 plus 3, which gives me 13 plus 6x. So 10 plus 3 by 2x plus 1 is equal to 13 plus 6x. So it's important for you guys to know that. All right. Um, Now, sometimes you might see, like, let's say I had 2 plus 3x take away 1. You see, when you don't have a term in front, directly in front of the bracket, assume that that number is 1, right? So just assume that it's 1. And when you're removing your brackets, you're going to just multiply each one inside by 1. Remember, you're not adding 2 to the 1, right? Because this literally is something else. So you'll say you'll keep the 2 by itself, and then you'll say 1 times 3x, which is 3x, and then 1 times negative 1 will give me minus 1. So then you have 2 take away 1 plus 3x. Notice that when I group my like terms, I group it with the sign that is in front of that term. So if I'm moving 1 closer to the 2, I have to move the whole negative 1, right? I wouldn't say 2 plus 1 because the question is actually 2 plus 3x minus 1. So wherever that minus 1 goes on that same side of the equation, it continues to be minus 1. The only time that a sign will change well, it wouldn't change in an expression, but it'll change if you were moving it from one side of the equation to the other side of the equation. But that's not the case here. I'm simply grouping my like terms. So 2 take away 1 is 1. I don't have any like terms with x, so it will just be 1 plus 3x. And similarly, you could have had, let's say you had 10 take away 2x minus 3. So this would be, well, remember, 10 is by itself, and we imagine that there's a 1 on the outside here. So this would end up being 10 by itself, and then you say minus 1 times 2x, which will be minus 2x, and then minus 1 times minus 3, a negative by a negative is a positive. So this will be 1 times 3, which is 3. And now this will give you 10 plus 3 minus 2x, which gives me 13 minus 2x. And that's just a little refresh, guys, for you to recall how to remove brackets. Again, it's important when you're doing the method of substitution to know how to remove brackets. All right. Now, let's say we have a problem. Say we have 3x plus 5, right? And I want to make the substitution. So I want to find out. So what is the value of 3x plus 5 when x is equal to 3? So what is the value of 3x plus 5 when x is equal to 3? This literally means what would be the answer? Like, what would be the value of the expression if I substituted x is equal to 3 instead? You'll already know that when you're substituting a value into an expression, you replace the, the variable with whatever the value is. So x is 3. Now that means, now this expression, 3x plus 5, this literally means 3 multiplied by x plus 5. So if I had to substitute x is equal to 3 into 3x plus 5, it'll be 3. Notice I use my brackets. So 3 brackets 3, which means 3 times 3 plus 5. And that would give me 3 times 3 is 9, and 9 plus 5 is 14. So the value of 3x plus 5 when x is 3 will be 14. Because if x is 3, that means it will be 3 times 3 plus 5. Okay? So those are just some things I want you to call to mind. At this point, I'm going to give you all a few questions just with like simple removing brackets. I just want to make sure that you all know how to do it. So I'm going to write the questions here on the screen. I want you to send me your work. I'm going to write the questions here. So these are for you to try. I want to see it in your, write them down in your book and send it to me on WhatsApp, okay? So try for me. 3 by x, 3 by x plus 2. This is a 4. Let me write this better. 4 times 2x minus 6. Six times 4 minus 3x. Negative 2 by 4 minus 2x. And finally, right. So you're going to try these for me, please. Send it to me in your on WhatsApp. So write them down in your book, send it to me on WhatsApp. Let me just pause the recording for a while. Okay, guys. What you said looked good. Everybody seems to understand the hang of it, right? So 3 times x plus 2 will be 3 times x plus 3 times 2. So that will be 3x plus 6. 4 times 2x minus 6 will be 4 times 2x, which is 8x. And then 4 times minus 6, which is minus 24. Then 5 times 3x is 15x. And 5 times minus 3 would be minus 15. 6 times 4 is 24, and 6 times minus 3x will be minus 18x. Negative 2 times 4 will be negative 8, and negative 2 times negative 2x will be plus 4x. And finally, negative, remember it's like a 1 here, right? So negative 1 times 3x will be negative 3x, and then negative, sorry, I wrote that really badly. And then negative 1 times positive 2 will be negative 2. All right, so there you go. Now, let's look at substituting a full expression in another expression. So let's say I have 3y take away x. Yes, just 3y take away x, right? And I want to simplify this expression when y is equal to 2x plus 1, right? So just like the others, where I just, like this previous one, sorry, when I was doing 3x plus 5 to find the value of the expression when x was 3, and I substituted x is 3 into the expression. For this one, though, I have 3x, so consider the expression, consider the expression 3y minus x, right? And let's y equal, you know what? Sorry, guys, I'm writing this real bad. All right. So consider the expression 3y minus x. Let's y equal 2x plus 1. All right. And now simplify the expression. So if y is 2x plus 1, simplify the expression 3y minus x. In other words, wherever I see y in that expression 3y minus x, I want to replace it with 2x plus 1. So in other words, I'm substituting, right? So I'm substituting, much easier to just write substituting y is equal to 2x plus 1 into the expression 3y take away x. Now the expression 3y take away x, the expression 3y take away x literally means 3 times y take away x. So wherever I see y, I want to replace it with 2x plus 1. So therefore, this substitution would look like 3. Now you have to use your brackets. If you do not use your brackets, you're going to end up with something looking crazy, right? So this will be 3 by y, which is equal to 2x plus 1. So 3 times 2x plus 1 minus x. Let's see what that would give me. Well, we just reviewed how to remove these brackets. So this will be 3 times 2x, which gives me 6x, and then 3 times 1, which is 3. And then I still have minus x on the outside here. So that will be 6x plus 3 minus x. Grouping like terms will be 6x minus x plus 3. So this gives me 6x minus x is 5x. And then I don't have any like terms with 3, no other constants. So this will just be 5x plus 3. All right, so you can substitute a value into an expression, but you can also substitute an expression into another expression. So for the expression 3y minus x, and you would notice that I'm saying expression and not equation, right? The reason I'm not saying equation is that an equation has an equal sign. It has two sides, right? Separated by an equal sign. An expression is just some terms together with a sign, right? So like an expression is like a phrase, for instance. It's not complete. An equation, you can think of it as a sentence. It is complete, right? So an expression might be the cat on the wall. The cat on the wall doesn't tell me anything. What about the cat on the wall? What is the cat on the wall doing? But if you say the cat is on the wall, well, that's a complete sentence, right? Because the cat is on the wall. That tells you where the cat is. Cool. So an expression is like a phrase, it's not complete. An equation is a complete sentence, all right? And you have an equal sign. So the expression 3y minus x, if y is equal to 2x plus 1, then that expression, when I substitute y is equal to 2x plus 1 into it, will give me 3 times 2x plus 1 minus x, because 3y literally means 3 times y. So 3 times the expression for y minus x. And then you just remove your brackets and work it out, right? So let's look at another one. Let's say that I want to substitute the same y is equal to, so let's substitute sub in y is equal, same 2x plus 1 into, what can I say? Into 5x take away 2y, right? So I want to substitute y is equal to 2x plus 1 into 5x minus 2y. That means wherever I have y in this expression, I'm going to replace it with 2x plus 1. Be sure to use your brackets. So let's go. So that would be 5x, because I'm not doing anything there, minus 2 times y, and y is 2x plus 1. So brackets, 2x plus 1. And now I'm going to expand my brackets and simplify. So this would be 5x remains by itself, nothing to do with it as yet. Negative 2 times 2 will be negative 4x. And then minus 2 times 1 is minus 2. So thankfully, my x terms are already next to each other. So I could just say 5x take away 4x, which gives me x, and then minus 2. So that's how you substitute an expression for one of the variables in another expression. All right, guys? And this makes up the basis of substitution method when you're solving simultaneous equations. That's why I'm going through it with you right now. So make sure you have this down. If you don't have it, take a screenshot or take a picture or something, because I'm now going to give you some to try for me. Right. So you're trying these. So let's x equal 3y minus 2. And you're substituting that into 5y plus 2x right? So you'll let x equals 3y minus 2. Find 5y plus 2x, 10y plus 3x, 4y plus 4x. Let's say 10x minus 3y, 3x plus 5y. Finally, 4x take away 2y. Okay? Oh, actually, no, I want to change this last one. The 4y take away 4x. Yeah. So you're doing those for me. Send it to me, please, when you're finished. And right. So if x is 3y minus 2, and you need to substitute that into 5y plus 2x, that would literally mean 5y plus 2 times whatever x is. X in this case is 3y take away 2. All right? So expanding, you'll get 5y plus 2 times 3y, which is 6y, and then 2 times minus 2, which is minus 4. So this will give me 5y plus 6y, which is 11y minus 4. All right? So if you got this, good job. If you didn't, check and see where you may have gone wrong. And if you do not understand where you went wrong, send it to me. Let me know. We'll go through it. Number 2, we have 10y plus 3x. So again, you're replacing x with the 3y minus 2. So that would be 10y plus 3 times y, sorry, 3 times 3y minus 2. So that would give me 10y, 3 times 3y, which is 9y, and then 3 times minus 2, which is minus 6. So that gives me 10y plus 9y, which is 19y minus 6. Number 3, I think I should use a different color. Number 3 is 4y plus 4x. So that is 4y plus 4 times whatever x is. In this case, x is 3y minus 2. So this gives me 4y plus 4 times 3y, which is 12y, and then 4 times minus 2, which is minus 8. Simplifying that, 4y plus 16y, sorry, 4y plus 12y is 16y minus 8. That's your answer. Number 4, we have 10x minus 3y, so that would be 10 times x. X in this case is 3y take away 2. So, and that minus 3y. So that will give me 10 times 3y, which is 30y. And then 10 times minus 2 is minus 20. And then minus 3y. So this would be 30y minus 3y is 27y minus 20. And then we have number 5. Oh, wait, Sarah, I think we have a mistake in yours. Check it and let me check it back, okay? In number 4. Number 5, we have 3x plus 5y, so that'll be 3 times x, which is 3y take away 2 plus 5y. So that would give me 3 times 3y is 9y, and 3 times minus 2 is minus 6 plus 5y. So this gives me 9y plus 5y, which is 14y minus 6. And then finally, 4y minus 4x. So that would be 4y, take away 4 times x, which is 3y minus 2. So that would be 4y, take away 4 times 3y, which is minus 12y. And then minus 4 times minus 2 is plus 8. So 4y take away 12y is minus 8y plus 8. All right, so I did get some of your work. I didn't get to correct all of them. So I want you to make sure, check it back and see if you made any errors and tell me where your errors may have been. Okay? And if you don't understand, let me know. Right, guys. So this makes up the basis of substitution. So let's look at solving simultaneous equations by the method of substitution. Okay. So, so far we've done simultaneous equations, solving simultaneous equations using the elimination method. Elimination method, as its name suggests, you eliminate one of the variables so that you're only left with one variable so that you can solve the equation, right? With the substitution method, we find and we equate the variable to an expression. Here's what I mean. Let's say we have the question to solve, so solve x minus 2y is equal to 7 and 3x minus 4y is equal to 22. And we need to solve this pair of simultaneous equations. So using the elimination method, we would have either multiply equation 1 by 3 and then subtract it, or multiply equation 1 by 2 and add it, right? But with the substitution method, we need to make x or y the subject of the formula or the subject of the equation, right? Now, it's always easiest to choose the variable that has a coefficient of 1. So as you can see in these two equations, x, the coefficient of x in equation 1 is 1. So the objective is to get either 1x is equal to something or 1y is equal to something. I'll always choose the variable that has 1 as its coefficient. And the reason I do that is because I don't want to end up with fractions. We are going to do ones that have fractions. But for this example, we're using x, right? So from 1, right? So using equation 1, x is actually equal to 7 plus 2y. All I did there is I moved minus 2y to the other side of the equation. So x will now be equal to 7 plus 2y. Once I have x by itself, right? So once I have x by itself, so x is equal to something, then I can substitute that into the other equation. So let's say x is equal to 7 plus 2y. Let's call that equation 3, right? And now I'm going to substitute sub in equation, sub in equation 3. Now you must substitute it into the other equation, not the one that was used to get the substitution, but in the other equation. So you see how I used 1 to get x is equal to 7 plus 2y? I need to use equation 2 now. So I'll substitute that x is equal to 7 plus 2y into equation 2. So I'm substituting that into equation 2, which means wherever I have just like these, right? Just like this, when x was 3y minus 2, how I substituted it into the expression is exactly what I am going to do here, except I'm substituting it into the other equation. So this equation is 3x minus 4y is equal to 22, right? So if I'm substituting equation 3 into that, it means wherever I have x, I'm replacing it with 7 plus 2y. So make sure to use your brackets. So equation 2 is 3 times x, so that will be 3 brackets 7 plus 2y, close brackets, minus 4y is equal to 22. All right? So I have successfully substituted x is equal to 7 plus 2y into equation 2 by simply replacing x in that equation with 7 plus 2y. Now I remove my brackets. So 3 times 7 is 21. 3 times 2y is 6y minus 4y is equal to 22. And the objective here is to get an equation with one variable because you can solve an equation with one variable. So 21 plus 6y minus 4y. Well, 6y minus 4y. So this will be 21. 6y minus 4y is 2y. So 21 plus 2y is equal to 22. And therefore, 2y is equal to 22. Take away 21, which means 2y is equal to 1. And therefore, y is equal to a half. And you can get y being equal to a fraction or a decimal. It wouldn't always be a whole number. Now that I have y is equal to a half, I substitute that. So I'm now going to substitute y is equal to a half into any one of the equations. I'm going to substitute it in equation 3. So that would be x is equal to 7 plus 2 times a half since since y is a half. So that would give me 7. So x is equal to 7 plus 2 times a half is 1. So x is equal to 8. So my solution to this pair of simultaneous equations, my solution is x is equal to 8 when y is equal to a half. All right, so let's go through these steps again. Your first step, well, you label your equations 1 and 2. You rearrange the equation in which the coefficient of x is 1 to make x the subject of the equation or the subject of the formula. So using 1, x is equal to 7. So when you're making x the subject, it just means that you move everything from that left-hand side that is not x to the right-hand side. So I need to move minus 2y to the right-hand side. And when you move a term that is minus on one side to the other side of the equation, it will now be plus. So instead of minus 2y, it will now be plus 2y. So I have this new equation, x is equal to 7 plus 2y. All right. Now that I got a substitution for x, it means I can now replace x with that expression in the other equation. So it cannot be in equation 1. It has to be in the other equation. The reason is that I use equation 1 to get this substitution. So therefore, I will substitute that equation 3 into equation 2 by simply replacing x with 7 plus 2y. So wherever I have x in equation 2, I'm going to replace it with 7 plus 2y, just like you just did in the examples, in the exercise we completed just now. So that'll be 3 times 7 plus 2y minus 4y. I remove my brackets, as you know how to do, and then I solve for y. And once you get what y is equal to, you can then substitute that value of y into any one of the equations. I chose to do equation 3 because it's already x is equal to that. So I would just have to simplify the right-hand side. Okay, so that's how you solve an equation using the substitution method. Let's look at another example. So say I had x minus 3y is equal to 1, and then 2x minus 5y is equal to 3. So first things first, I'm labeling my equations. This is equation 1, and this is equation 2, right? As I said, choose the equation in which the coefficient of any one of the variables is 1. It could be y as well as, just at these examples, it's x. So I'm going to choose equation 1, and I'm going to rearrange that equation to make x the subject. meaning to have x is equal to something. I want x by itself on the left-hand side. So using equation 1 would give us x is equal to 1. Well, this is minus 3y. So when I move it to the other side, it will become plus 3y. So x is equal to 1 plus 3y. We're going to call this equation 3. All right. And now you're going to substitute equation 3 into the second equation. This is equation 2. So wherever I have x in equation 2, I'm going to replace it with 1 plus 3y. So equation 2 is 2x minus 5y is equal to 3. So this will be 2 brackets 1 plus 3y, since x is equal to 1 plus 3y. And then the rest of the equation remains the same. So 2 times 1 plus 3y minus 5y is equal to 3. Now I simplify and solve for y. So 2 times 1 plus 3y will be 2 times 1, which is 2. 2 times 3y, which is 6y, minus 5y is equal to 3. So then simplifying this side, you'll get 2 plus 6y minus 5y is just 1y. All of that is equal to 3. So y is equal to 3, take away 2, which makes y equal to 1. And once you have what y is equal to, you could then substitute y is equal to 1 into, I'm going to do it in equation 3 because it's already x is equal to that. So it's a simple substitution and simple simplification. So substituting y is equal to 1 into 3 would give me x is equal to 1 plus 3 times y, so 3 times 1, which will be x is equal to 1 plus 3, which is 4. So my solution here to this pair of simultaneous equations, x is equal to 4, y is equal to 1. Right? Let's do another one. Let's say we have 3x minus 2y is equal to 1, and then x plus 3y is equal to 4. So first things first, I'm going to label my equations. This is equation 1. This is equation 2. In these two equations, you have the coefficient of x as 1 in equation 2. So I'm going to use that equation using equation 2. I'll get that x is equal to 4 take away 3y, right? Because it's x plus 3y. So if I move plus 3y to the other side of the equation, it becomes minus 3y. And this is my new equation 3. Once I get that, I have an expression for x. I'm now going to substitute that expression. So substituting 3 into the first equation this time, because I cannot use the same equation that I got the substitution from, right? I have to use the other equation. So I'm substituting 3 into equation 1. That means wherever I see x, I'm going to replace it with 4 minus 3y. So this would mean it would be 3, it's 3x, which is 3 times x. So that would be 3 times 4 take away 3y, take away 2y is equal to 1. So simplifying and solving now for y, I get 3 times 4, which is 12. 3 times minus 3y is 9y. Well, minus 9y minus 2y is equal to 1. So this would be 12 minus 9 minus 2 is minus 11. So that's minus 11y is equal to 1. Therefore, minus 11y is equal to 1 take away 12, which means minus 11y is equal to minus 11. And so y is equal to minus 11 divided by minus 11. A negative divided by another negative will be a positive. So 11 divided by 11 is 1. Y in this case as well is 1. Once I get what y is equal to, I can substitute that So substitute y is equal to 1 into any one of the equations. I'm always going to use the simplest one. So I'm going to use equation 3. But honestly, it wouldn't matter whichever one you use. Once you do your correct substitution, you're going to get it correct. And correct algebraic steps, you're going to get it correct. So substitution y is equal to 1 into 3 would be x is equal to 4 take away 3 times 1. That is 4 take away 3, which is 1. So for this one, the solution is x is equal to 1 and y is also equal to 1. All right, guys. I actually want you all to wait. Actually, I'm going to do one more with you guys, and then I'm going to give you all a few to try for me. So let's look at this one. Here we have 2x plus y is equal to 5, and 5x minus 2y is equal to. So this is my first equation. This is my second equation. Now, in the previous examples, we had x being the one with the coefficient as 1, and we just rearranged that equation to make x the subject. In these, in these two equations, however, y is the variable that has the coefficient of 1. So I'm going to have to rearrange equation 1 to make y the subject. Now, if that's the case, I will write using 1. I'll get y is equal to 5 take away 2x, because this is plus 2x here. So if I move it to the other side, it will become minus 2x. So this is my equation 3. And now that I have an expression for y, I will substitute that. So substitute in equation 3 into the second equation. That gives me 5x minus 2. Now remember, it's wherever I see y, I'm replacing it with 5 minus 2x. So it'll be 2 brackets, 5 take away 2x is equal to 8. Now I move my brackets, I simplify, and I solve for x. So this will be 5x minus 2 times 5 is minus 10. Minus 2 times minus 2x will be plus 4x. And all of that is equal to 8. So 5x plus 4x is 9x. That means 9x minus 10 is equal to 8. So then 9x will be equal to 8 plus 10. That gives us 9x equal 18. And if 9x is equal to 18, x is equal to 18 divided by 9, which means that x is equal to 2. And once I get what x is equal to, I can now substitute it. So I'm going to substitute x is equal to 2 into equation 3, since that would be the simplest equation to substitute it into. So that would be y is equal to 5 minus 2 times x. So that'll be 2 times 2. Y is equal to 5 minus 2 times 2 is minus 4. So this one, y is equal to 1. So therefore, my solution to this pair of simultaneous equations, x is equal to 2, y is equal to 1. All right, guys. So I want you all now to try for me. You are trying and try to follow your steps, the same steps that we did here. If you're stuck, send me a message, please. So I will go through it again though. So try something. So you're trying these for me. Number 4, x minus 5y is equal to 6, while 2x minus 13y is equal to 15. Right? So you're doing that one. And then you're doing x plus 3y is equal to 10. Then 5x minus 2y is equal to negative 1. Please try these two for me. Waiting to see your work. Right, I'm gonna go on a new slide. So this is the first one is number 4 is x. Why am I writing so tiny? Yeah, it's x uh minus 5y is equal to 6, and then 2x minus 13y is equal to 15. All right, so let's label our equations. This is equation 1, and this is equation 2. So from 1, you could write the word from as well, that's fine. And lots of people write from, doesn't matter if you say using or from. So using equation 1, and the reason I'm using equation 1 is because I have x by itself there, meaning like I have the coefficients of x as 1. So I'm going to rearrange equation 1 to make x the subject. That means I want x by itself on the left-hand side. So x is equal to 6. Since this is minus 5y, when I move it to the other side of the equation, it becomes plus 5y. So x is equal to 6 plus 5y. That is my third equation. Now that I have an expression for x, I am going to substitute that. So subbing 3 into second equation. You have to do it in the other equation, not the equation from which you got the substitution for x. So the second equation is 2x minus 13y is equal to 15. So I'm replacing x with 6 plus 5y. So this would be 2 times 6 plus 5y, since it's 2 times x. 2 times 6 plus 5y minus 13y is equal to 15. 2 times 6 is 12. 2 times 5y is 10y minus 13y is equal to 15. So this would be 12. 10y take away 13y is minus 3y. So all of that is equal to 15. And therefore, minus 3y is equal to 15 take away 12. Now, guys, this minus in front of the 3y has to come down to the next line with the 3y because it's on the same side of the equation. The only time that this minus would change to plus is if I was moving 3y to the other side of the equation. But because it is still on the same side of the equation, I must bring that sign down with it. So I'll get minus 3y. This 12 is plus 12. So when I move plus 12 to the other side, it will be minus 12. So you get minus 3y is equal to 15 take away 12, which is 3. So y is equal to 3 divided by negative 3. And that would be y is equal to negative 1 because a positive divided by a negative gives you a negative. Now that I have what y is equal to, I can substitute that. So substitute y is equal to negative 1 into any one of the equations. So I'm going to substitute it in equation 3, the simplest one. So that is x is equal to 6 plus 5 times negative 1. Therefore, x is equal to 6. 5 times negative 1 is minus 5. So x is equal to 1. So my solution here is x is 1 and y is negative 1. How do I know if my solution is correct? Well, just like with any equation, you substitute the value that you got for x and y, well, the values that you got for x and y back into both equations. Now, oftentimes, you might substitute it in one equation and it will work out. The left-hand side will be equal to the right-hand side. But you might substitute it in the second equation, it doesn't work out. So you have to do it in both. It has to work out where the left-hand side is equal to the right-hand side in both equations. So Substituting x is 1 and y is -1 into equation 1. Equation 1 is x minus 5y is equal to 6, right? So I need the left-hand side to also be equal to 6. So x is 1 and y is -1. So that would be 1 take away 5 by -1. That would be 1 minus 5 by -1 is +5. So here it works out because the left-hand side is equal to the right-hand side. So it substitutes correctly into equation 1. We need to still check it in equation 2. 2x minus 13y is equal to 15, right? So I would need left-hand side to also be equal to 15. So that would be 2 times x, so 2 by 1 minus 13 by -1. Let's see, 2 by 1 is 2, minus 13 by -1 is plus 13. So that it works out, right? 2 plus 13 is 15. So you have 15 is equal to 15. Left-hand side is equal to right-hand side. So that means that my solution is correct. And that's how you actually check if your solution to a pair of simultaneous equations is correct, right? Um, like I said, you have to do the substitution in both equations because oftentimes it'll work out in one and it may not work out in the second one. And that's actually how I check when you send me your work. That's how I check to see if your answer is correct. Before even looking through your steps, I just substitute the values back into both equations to see if it works out. And once it works out, well, I know your steps correct anyway. If they don't, then I go back and I look at your steps to try to find your error. And that's the same strategy that you should use in correcting your own work. So I am going to do the next question as well. Going on a new slide. Don't worry if you didn't get this. I am sending it after. Right. So number 5 was x plus 3y is equal to 10. And then 5x minus 2y is equal to -1. All right, so let's see what we get here. Well, this is equation 1, and this is equation 2. Again, I have 1x in equation 1, so I'm going to use equation 1 to make x the subject. I'm keeping x on the left-hand side, and I'm moving 3y to the right-hand side, so it will become -3y. And that is my third equation. Now that I have that expression for x, I'm going to substitute it into the other equation. So substituting 3 into equation 2. That means wherever I see x, I'm going to replace it with 10 minus 3y. So the equation is 5x, which literally means 5 times x. So 5, and in brackets, 10 minus 3y. That's what x is equal to. And that minus 2y is equal to -1. Let's expand our brackets and simplify. So 5 times 10 is 50, and 5 times minus 3y would be minus 15y, minus 2y is equal to -1. So this, simplifying this again, 50 minus 15 take away minus 2. Sorry, minus 15 take away 2 is minus 17y. Yeah, did I make a mistake? No, 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 it's good. Right. So 50 minus 17y is equal to -1. So then I have minus 17y. Remember, it's going to remain as minus 17y because I have it on the same side of the equation, right? So that sign, you do not just drop it. You keep it. You do not change it because it's still on the same side of the equation. So it's still minus 17y is equal to -1. I'm moving 50 to the other side of the equation. So it's going to become minus 50 because 50 on this side of the equation is positive. So this would be minus 17y. Minus 1 take away 50 would be minus 51. And then y, if minus 17y is equal to minus 51, y is equal to minus 51 divided by minus 17. Minus 51 divided by minus 17 is positive 3. So y is equal to 3. Now that I have what y is equal to, I'm going to substitute y is equal to 3, and oops, not like that. Y is equal to 3 into equation 3. So that would give me x is equal to 10 minus 3 by 3. So x is equal to 10, take away 9. That means x is equal to 1. And to check if my answer, my solution is correct, I substitute both x is 1 and y is 3 into equation 1 first, right? Which is x plus 3y is equal to 10. So x is 1, so that'll be 1 plus 3 times y is 3, so 3 times 3 is equal to 10. That does work out because 1 plus 9 is 10. So here I have the left-hand side being equal to the right-hand side. It substitutes correctly into equation 1. Now to substitute it into equation 2, I would have 5 by x, which is 1, plus, minus 2. Let me write over the equation. 5x minus 2y is equal to negative 1. So 5 by x is 5 times 1 minus 2 by 3, since y is 3, is equal to negative 1. 5 times 1 is 5. 2 by 3 is 6. Minus 5 take away 6 is negative 1. So here I see that the left-hand side is equal to the right-hand side. I know that my solution is correct. I'm going to do some more. And don't worry, I will send you all some to practice for homework, but I want to do as many as I can with you guys. All right, number 6. This one is interesting. Here I have 3x minus y is equal to 6, and 2x plus 3y is equal to 15. This is my equation 1, and this is my equation 2. Now, unlike the others, I haven't done any where the coefficient of the variable is negative 1, right? In this one, as you can see, it's 3x minus y is equal to 6. I want to make y the subject, not negative y, but y, right? So what I'll do is I'm going to rearrange this equation to make y positive and to make it positive 1y, right? So from equation 1, using equation 1, what I'll do is I'm going to move 6 to this side and move y to that side. So this will be 3x take away 6 is equal to y. Because, guys, I have moved negative y to the right-hand side, so it will become positive y. And I move positive 6 from the right-hand side to the left-hand side, so it becomes minus 6. So this is, I can rewrite this as y is equal to 3x minus 6. It's the same thing. If 3x minus 6 is equal to y, you can just switch it and write y is equal to 3x minus 6. I haven't changed anything there. So now I have my equation 3. All right. And now that I have my equation 3, I'm going to substitute that. Substitute equation 3 into equation 2. That means wherever I see y, I'm going to replace it with 3x minus 6. So this would be 2x plus, well, it's plus 3y. So that's plus 3 times 3x minus 6 is equal to 15. Now I remove my brackets and I simplify. So 2x plus 3 times 3x is 9x. 3 times minus 6 is minus 18. All of that is equal to 15. 2x plus 9x is 11x. Minus 18 is equal to 15. So then 11x is equal to 15 plus 18, What is 15 plus 18? 33. So then 11x is equal to 33. So x is equal to 33 divided by 11, which means that x is equal to 3. Now that I have that x is equal to 3, I'm going to substitute that. So substituting x is equal to 3 into any one of the, well, not anyone. I always say just do it in equation where y is the subject. So it will be equation 3. That is y is equal to 3 times x, so 3 times 3 minus 6. So y is equal to 9 take away 6, which means y is equal to 3. Right? So my solution here is x is 3 and y is also 3. Now, before we even check to see if the answer is correct, I want to show you if I had to rearrange equation 1, right? So like if I had to do it a different way. So if I have 3x minus y is equal to 6, I could still move 3x to the other side. So I could say minus y is equal to 6, take away 3x. And then to get rid of this minus, I could just multiply throughout by minus 1. So this will give me minus y times minus 1, which will be y. 6 times minus 1 will be minus 6. And minus 3x times minus 1 will be plus 3x. And rewriting this to put the positive number in front would be y is equal to 3x minus 6, which is what we got here, right? But as you can see, this was much easier and way less steps to do than doing it this way, right? But if you are comfortable doing it like that, that's fine. You're still gonna end up with the same substitution. Y is equal to 3x minus 6. But something to be very mindful of is that you need a positive 1 as the coefficient, not minus 1. So you don't want minus y is equal to something. You want positive y is equal to something. And now checking to see if our answers are correct. In equation 1, it's 3x minus y. So let's see. 3 times 3 minus 3 is equal to 6. So it's correct there. And then the second one, 2 times 3 plus 3 times 3. Well, that's 6 plus 9, which is equal to 50. So it substitutes correctly into both equations. Right? So which method do you guys prefer? Joshua, which one do you prefer, the elimination or the substitution method?
The elimination.
Yeah, what don't you like about the substitution?
I don't know, I guess elimination, I grasp it better.
Yeah, I prefer elimination as well, to be honest. Any of you prefer the substitution method? Actually, like teaching it makes me like it more, but I am like biased towards the elimination method. Matthias, which one do you prefer? Elimination or substitution?
Elimination.
Elimination, okay. What about use of Zara? Elimination or substitution?
Elimination.
I assume it's the same for Safira and Shania. Feel like all of y'all prefer the elimination. Now you still have to learn the substitution, right? I don't think that in CSEC I've never really seen them tell you you have to use substitution. Um, you get to use whichever method you prefer. But in your end of term test, maybe your teachers might ask you to use a specific method, right? Now you get marks for like if you made a mistake, for example, like if you got the wrong thing for X, then it follows that you'll get the wrong thing for Y because you're gonna just continue substituting that wrong value into the next equation. So you'll get something called ECF, which is error carried forward. Once you consistently carry the same error from start to finish, you're still gonna get a mark for that consistency in your logical flow, in your solution, but you wouldn't get the full mark because, well, your answer is not correct. So I want to show you all, and this will be the last one that I'm gonna do. Actually, two of them, and then I'm going to send you all. I would like you all to try two for me, at least two full questions, so I can see how you're doing with it. right? But I want to show you all, not all the time the coefficients of the variable will be 1 off the bat. Sometimes you might actually have to do something further and you'll end up with an algebraic fraction. So let's say we had um 4x plus 3y is equal to 10, and then 5x minus 2y is equal to 1. And let's say this is equation 1, and this is equation 2. Right. Neither of them, as you can see, in no equation here do you have the coefficients of x or y as 1. So we have to do one step further, right? So I'm going to use equation 1 since they're all positive here. Using equation 1, and I'm going to make x the subject, right? So using equation 1, I would have 4x is equal to 10 take away 3y. And then if 4x is equal to 10 take away 3y, then x will be equal to 10 take away 3y all divided by 4. And this would be my third equation. Once you get what that substitution is, you're going to, just like before, you're going to substitute that into the other equation. So substituting 3 into equation 2. Don't know if you all did fractional algebras yet, but I'm still going to show you all this one. We'll do some fractional algebra, actually. We'll get around to doing that. Okay, so substitution equation 3 into equation 2, wherever I have x, I'm replacing with 10 minus 3y over 4. So that would be 5 times 10 minus 3y over 4 minus 2y is equal to 1. So this looks awful already. If I had a choice, I would not actually use substitution when the coefficient is not 1, right? Anyway, so let's go. So this would be 5. But if I want to remove these brackets, it will be 5 times 10 minus 3y all over 4 minus 2y is equal to 1. So then this would give me, removing the brackets here, that would be 5 times 10, which is 50. Take away 15y all over 4 minus 2y is equal to 1. So then this would be 50 minus 15y all over 4 minus, sorry, is equal to 1. I'm going to move plus minus 2y to the other side. So that would be plus 2y. Now I'm going to multiply both sides by 4 to get rid of this denominator. So this will end up being, on this side, if I multiply by 4, I'll get rid of the denominator. So it will be 50 minus 15y is equal to 4 plus 8y. I multiplied both sides by 4. And now I'm going to group my y terms on one side and my constants on the other side. So this would be minus 15y take away 8y is equal to 4 take away 50, which is minus 15 minus 8, I think is minus 23. Minus 15 minus 8 is, yeah, negative 23y is equal to 4 take away 50, which is minus 46. I know this looks real bad. You're probably hating this right now. And then if minus 23y is equal to minus 46, then y is equal to minus 46 divided by minus 23, which makes y equal positive 2. Now that I have what y is equal to, I can substitute y is equal to 2 into any one of the equations. So this one, I'm substituting it into equation 3 still. So this would be x is equal to 10 take away 3 times 2, all divided by 4. That would be 10 take away 6, all divided by 4, which is 4 over 4, which is 1. So this got quite complicated because you have a fractional part in as the substitution. And this is not the only way that you could have solved this equation, by the way. You could have solved it in a different way as well. You're still going to end up with x is 1 and y is 2. And to check if my answer is correct, I will substitute x is 1 and y is 2 into equation 1. So that would be 4 times 1, 4x, plus 3 times y, that's 2. And 4 times 1 is 4, plus 6, which is 10. So it works out in equation 1. In equation 2, it's 5 times 1, take away 2 times 2, which is 5 take away 4, which is 1. So it works out in equation 2 as well. My recommendation is to always use elimination if you have different, if none of the coefficients of the variables, if none of them are equal to 1, use elimination. It is much easier than doing fractional algebra, right? Even though you have to get comfortable with fractional algebra, it's so much easier to make a mistake with that. And it's just way easier to do elimination than substitution when you have a question like this. Because if we had to do this with elimination, let's do it. It would be, hold on, just to bring things back a little bit. If I had to do this with elimination, that's 4x plus 3y is equal to 10. And then 5x minus 2y is equal to 1. So this is equation 1, and this is equation 2. I need the coefficients to be the same if I'm using elimination. So to get rid of, I'm going to use 3 and 2 because it's smaller numbers, and the LCM of 3 and 2 is 6. So I will multiply equation 1 by 2 to give me 4x times 2 is 8x, 3y times 2 is 6y, and 10 times 2 is 20. So that's equation 3. Then I'll multiply equation 2 by 3 to get 5x times 3 is 15x, minus 2 times 3 is minus 6y, and then 1 times 3 is 3. So this is my equation 4. Since I have different signs, when you have different signs, you add the equations. So it'll be 6 plus minus 6. So that will give you the 0, right? So I'll say equation 3 plus equation 4. 8 plus 15 is 23. So 23x plus 6y minus 6 plus minus 6y will be 0. And then 20 plus 3 is 23. So x will be equal to 23 over 23, which is 1. And then I substitute x is equal to 1 into any one of the equations. So substituting x is equal to 1, let's say into equation 1, would give me 4 times 1 plus 3y is equal to 10. So 4 plus 3y is equal to 10, and therefore 3y is equal to 10, take away 4, which means that 3y is equal to 6, and y is equal to 6 divided by 3, which is 2. Oh my gosh, look how much easier and how much less steps you would have had to do if you use elimination versus substitution for this one, right? Same answer, x is 1, y is 2, but much easier algebra. And that's the thing, with solving simultaneous equations, you will still get the same answer, whether you use elimination or substitution, provided that you do the correct steps algebraically, right? So we're gonna wrap up here for today, guys. And I'm sending you 2 questions, just 2. I want you all